All right, so now we're on the record. My evaluation period for Visual Studio has ended, so let me take care of that. Come on. Okay. Loaded my personal settings, which won't look very nice from the back of the room. There's you can change the font to whatever you want in Visual Studio, and there's an online tool that allows you to create a font out of your handwriting. I tried that with coding, and it doesn't look good, so I wouldn't recommend it. Maybe your handwriting's better than mine, but let's see how we change the theme back. Okay, is that visible in the back there? Legible? Yeah. So the first exercise was to write a method. So the first thing we're going to do is start by declaring a method signature. And the first thing we need to know is the return type. And since we can see that in multiple places it says returns its value as a string, we know that the return type is string. And then we need a method name, and the rules don't require us to call it anything, so we can call it my method. And now input arguments. The first rule says it needs to take an integer. So there we have. Oh, that's our other method. Never mind. So we have this method signature. This is the start of our method that we needed to create. And it's Visual Studio is complaining right now because not all code paths return something, which is true, because we need to return a string with this method, and nothing's being returned yet. The first thing we needed to do was test to see, let's see, if the integer is even, do this. If the integer is odd, do this. If the value isn't within the range, return an error message. So the first thing we want to do is actually check to see if it's within the specified range of 1 to 100 inclusive.
And how did you know to put its value in those parentheses?
Because the first, let me pull this over here. The first rule says this method will take an integer. So we know it has an input parameter of an integer. So the first thing we want to do is to check. Oh, sorry. It's actually going to return a string. The rules say so for example, if the integer is even, add 1,000 to it and return its value as a string. It's going to be, so a string can be numbers. but it's still going to be a string type. A string of numbers is just like any other string of characters, except that you have number characters in there instead. So those are the difference between string and integer. They're different types, and so they'll have different methods associated with them and different things you can do with each one. So, for example, a string that was let's see an example real quick of a couple different types. So we can easily have a string that equals like this, but and then we can have an integer that equals the same thing. However, these are not going to be, if we did something like if value equals my int, that's not going to work because you can't compare a string and an integer like that, right? Because they're not the same type. And if likewise, if we wanted to do something like define a new integer value plus my int, won't work either, because even though my int looks like, or sorry, value looks like it's a number, it's actually a string as the data type.
So when it's a string, it sort of like treats it as though it's text?
When it's a string, it does treat it like text. This is just kind of under the hood. There's a type called char, which is just a character. And that's defined, you can define chars with single quotes. So for example, it won't let you do multiple characters in there because it's called a character literal. So they couldn't use double quotes because that's for strings. Okay? Sorry, I didn't catch the beginning of that. Not actually numbers, so it's basically an array, a list of characters. This is just a list of characters that this character is the character 1, the character 0. I mean, you could put O's here, and it still looks like an integer, but it's actually characters. This is a string still. Yep.
The best example of is adding 1 and 2 of the string, and adding 1 and 2 of integers. Adding 1 and 2 of the string, you get 12.
Yeah. Correct. Yeah. So when you add two strings together, we've seen that we can do this concatenation on strings, where this value is going to result in what 10001, right? Whereas if we did this, it's going to be 1001, because this is a math operation. And this is a string concatenation operation. So it's just appending, it's just taking that extra character down here and adding it to the end of this list of characters. So it's the things you can do with them is different because there's math operations and there's string operations.
Yeah, I was just going to add in, it's like a way to validate the only want numbers. That way you can, they put in A.
Yeah, this is the string type is just a bucket for characters. The code doesn't, it's only expecting characters to fit in this character shaped bucket. So you can't fit integers in there, even though they look the same to us, they don't look the same to the computer.
Versus string, my method, versus delay and update. What are those choices? I don't know what that means.
You're talking about here?
Yep.
So this is called the method signature. The method signature starts with a return type, Well, it has an optional scope declaration, public, private. Then it has a return type.
Return type, what is that? What is the return type? I'm like, you say void.
Yeah, void means that it doesn't return anything. So when you call this method, you're not expecting anything to come back from it. Let me show you an example. So if we, well, we have an example here, I guess. The int double. It's going to return an int, and we were expecting that. So when we had this guy, and we said int value y equals double value x, this method that we define down here returns an integer. So we can use this assignment operator to assign it to this new value. If this did not return an integer and it was void, we wouldn't be able to return anything like this. We wouldn't be able to return an integer. And we couldn't use it in assignment because it's not returning anything. It's not bringing anything back from this operation.
So string returns a string. What are the other types of void?
You can return any kind of object there is. You can return it in a method. You can return a game object, a string, a character, a float.
So those, but that's not a canary. Not any of it. It's those objects. You say there's a void, there's a string.
Yeah, this is the type that it's returning. Permanent types? Primitive. It can return primitive types. It can return any type. We could create a new type. It could return. So this new class we've created here is a type. We could return my behavior from one of these. And in that, we'd have to somehow generate a my behavior object and return it.
Is there a list though, like of types that are already predefined? Because when you type string, it already knows what string is.
There might be a list somewhere, but these are primitive types that are included in C#. I can try and find. I think
I don't know
what the options are, right?
Is part of the confusion for us because there are some constants like string and void, but they can also be variables that we can define ourselves, like my behavior. So, like, a list can't be finite if we can declare, if we can use anything we can come up with, right?
Yeah, it's whatever types you want to create. Just like a variable is defined first by a type. This is the same, these types right here are the same types you can return from a method. Anything you can define as a variable like this, you can also return from a method.
So it could be value x update.
No, this is a variable name. This is not a type. The variable name is just what you want to call it. We can call it whatever we want, and that's just we're naming the bucket that we're sticking an integer into.
Right, but you said that if we go back up to the top,
Yep.
my behavior, that we could set my behavior as what we're returning.
Yeah, you can also create new types.
That's what I'm saying.
And that's through this
So
class
in creating
definition.
new types, therefore types can be variables.
The type
Because
is not a
it's-
variable. This is not a variable. It's the name of the type we're creating. If we could look at the definition for this, and we're going to see that it's a struct is kind of like a class. We won't get into the differences, but it's basically use a struct if you're defining something with just data, and a class if it's also going to have methods. But assume this is a class as well. This is an int. It's called an int30. Well, maybe this is not a good example because there's a lot of details here. But let's look at a string maybe.
My point was only that a list of types can't be finite if they can be defined by the user.
The available types are not finite.
Right. That's what
There's not just there, but there is a finite list of built-in types, which is what Bonnie was asking about. I think is the ones that are built in. Yeah. Yeah, IntelliSense is going to pull up all of the built-in types, even if even our my behavior shows up in IntelliSense, because the compiler is constantly updating IntelliSense to show these are the available types, and it includes those built-in ones because those are included in. So deep inside this mono behavior, there's going to be using statements. Using brings in a whole nother namespace of, it's like a library where it brings in all the types and everything available to you. And deep inside mono behavior, one of the things that's being brought in is this string class. And we can see that that's a class string, and it has these methods available on it and this data available on it. And it's, you can see it's just a, like we said, you can define it with that char array, with its characters array. So it's just a list of characters. I think the slides I shared, or the glossary, has some various primitive types in it. Okay. I wouldn't, I mean, you can explore the types that are available, but really you don't need to know all the types available, because when you're creating a method, you're already going to have a good idea of what you want to return from that method. So you're not going to build something and looking at all the tools you have available and deciding which one you want to use then. You have an idea of what tool is needed for the job, and so you're going to go get that tool. It's the same with the return type. For example, in this one, we know that we want to return the value as a string. So we know that's the type that we want to deal with the string. We don't have to know that there's there's a type called tuple or anything like that.
Except when you get that error.
Which error message?
That tuples aren't available or something like that.
Oh.
I ran into a number of times.
Well, yeah, tuples aren't available here. There's it's probably in some kind of, that's in the system class here, or maybe somewhere else. But you don't have to know all. I mean, because there are as many types as you need available, if one of them, if the type you need isn't built in, you can make it. And you're not going to need to know all the, I mean, you might make something that already exists and name it something different. And that's okay if it's a simple thing. It's just going to be one of those things where you have to research and see if something like that is available. Because once you get into designing how the code is going to work, you're going to know what kind of data you want to return. And so you'll know through research or just through creating it yourself what kind of data you're going to be returning, what kind of type. This is one of those things that you'll just have to take on faith until the larger picture becomes clear. Any other questions on types? This error is because we haven't defined, we haven't set a return yet. It's saying that not all code paths return a value. Temporary, yeah. That's because you could have something like if true, return true, and this is one code path. Technically, it's always going to be true, so it's not going to complain. Let's do if value is less than 1. This may or may not be true. So this is one code path coming in that if the value is less than 1, return true. Otherwise, it doesn't have a return value. So this error is there because it's telling you that not all the paths through this method will return something. Because if you can't create a method, you can't define a return type and then not return anything, because the compiler is expecting something to be returned. So this error is not just there for a temporary thing. It's actually useful when you're creating larger methods as well, to make sure, because it's automatically parsing through all your code paths and seeing which ones return values and which ones don't.
Like,
What was that?
Why is it still
Because not all code paths return a value. So this is one code path. If the value is less than 1, then we're going to go in here and return true. But if the value was not less than 1, or it was equal to 1, then we're going to get down here to where there's no return. So that's exactly what it's saying, is not all code paths return value. This is one path to step inside of this this scope, and another path would you can imagine it to be like this else, where the else is just empty. This is the other code path. Yep. The code will, if you could find a way to compile it, it would run through if value is less than 1. Otherwise, it would crash. But it's not even, the compiler's not even going to let you create this situation. Because it's checking to see if it's making sure that for each, because you can think was when you're parsing through the code, you get these conditional statements, right? So it's a single, think of the time travel movies, right? Where they travel in time, they split the timeline into 2 then, right? So now that there's these 2 paths that you can go down. If the value is less than 1, you're going to go up here. If the value was something else, you're going to go down here. And so the parser is going to go through all those timelines, or all those branches, and it's going to check to see each one, because you could even get inside of here and have another branch. And now we have this one branch here, and the top branch branches off again into 2 more. And so it's this check for all code paths returning a value is very useful, because it can get complicated to make sure that all of those, that single branch, all branch out into multiple things. You want to make sure that all of those are able to come back to return a value. Does that make sense? Yeah. Well, so everything inside of an if, the if statement, everything inside the parentheses here has to evaluate to a Boolean, which is a true or false. Everything inside here has to go one way or the other, true or false.
Right. But what I'm looking for is like, so that's the value or INT, or what is there a place to know like what those operands are that are defined?
Yep, I'm going to go into Boolean algebra today, and that's Boolean algebra is part of evaluating, is what values are available here to check and what it's going to.
And for me, it may not even be more than anything else. But the other thing as well, like in general, like the right place to go to start what the pre-defined commands. But literally, like when I go, I have no idea what.
Well, yeah, that's fine. There's not really, I mean, there's so much stuff to learn in programming that there's not going to be like a general commands. I mean, we've seen a couple of them already. The inside of, so you're talking about things like an if statement? Well, so there's different categories. Like if, the for loops, those are all control flow statements. Those are all going to change the path of the code or make it loop back around or whatever it may be. Those.
I think she's looking for like a list of operators, like comparison things. Maybe the equivalent I could say is like an Excel, where you say if modulus, and then you put it, a button, basically you call it a function.
But I realize there's never going to be all, but like as a beginner, what are the ones
Well, and that's kind of the aim of this class, is to get those common things, and that's like the if conditional is a very common thing in programming. You're almost always going to use some kind of conditional statement, and that's the goal of this class, is to see what those common things are. And we can also look at operands as well. Like we're going to look at those in the Boolean logic today. Operators like this, the less than, the equality operator. We'll look at not, ors, ands. We'll look at all that stuff today. Okay, just stand right there. So let's get back to the method in exercise 1. And this is a great example of branching and how you can go down one path and there's multiple options for where to go next, and teaching is just like coding in that way, where you can have a myriad of branches and it looks like a maze at one point.
Unfortunately,
It's a little high.
it's higher than I could.
Yeah. That's all right. It should only be another half hour or so. Yeah. You could just have an aluminum foil hat. All right, so the first thing we wanted to do was to check to see if the value was in a specified range. And one way to do that is we wanted to check to see if so we want to make sure it's within, it's either 1, 100, or somewhere in between. And the less than and greater than signs are great for that. So we can say if value is greater than 100, we want to return an error string. So we're going to do a return with a string of value must be inside range 1 to 100. And so that's just one branch right there. Another branch is our if value is less than 1, we can return that same error message. And when we go into the Boolean logic today, I can show you kind of shortcuts for how you might combine these and stuff like that. So this takes care of our checking to make sure that the value is inside that range. If it's above the range, we're going to return an error value, and if it's below the range, we're going to return an error value. So that should take care of both the cases on either end of that spectrum. The next thing we want to do is test if it's even or odd. And we can do that with the modulus operator. If value modulus 2, basically this is a divided by 2 and give me the remainder. So if you remember your long division, you always had a remainder at the end when you're dividing with integer values. So if the modulus is equal to 0, which means there's no remainder after you divide by 2. If you divide an even number by 2, there's not going to be any remainder. If you divide an odd number by 2, this is going to equal 1, because there's going to be 1 left over that didn't fit into that 2. Yeah, this is it's the equality operator. And what it's going to do is, actually we can see here, it takes 2 values, a left and a right, and those will be placed on either side of the operator. And it's going to return a Boolean. The bool is going to be, and Booleans are true false, remember. It's binary. So it's going to return a Boolean that is true if these 2 values equal each other. So if it's an even number, this is going to equate into 0. And we can see that 0 is equal to 0. If this is an odd number, then this is going to equate into 1. And we can see 1 equals 0 is false. That's going to return false. The equality operator? Yes. And there's some kind of gotchas to that, which we won't have to go into. They're kind of being taken care of in a lot of the modern programming languages, but we won't go into that at the moment.
It's like the 1 equals 2 equals 3 equals.
Wait, what?
The 1 equal and 2 equal and 3 equals.
The 3 equals sign?
Yeah.
Well, I was talking about like saying if two strings equal each other. Sometimes it can check. In modern languages, this typically works. In other languages, this will return false because these are actually two different objects, even though they have the same contents. But we don't have to worry about that at the moment. So this we can put parentheses around this to make this a little clearer. We can see that this part right here is going to be 1 or 0. And then we're going to test to see if that is equal to 0. Right? So this is going to, it always evaluates, just like in any math operation, you evaluate from the inside out. And what that's going to do is evaluate to 1 or 0, and we're going to test to see if that's equal. Oh, did you get duct tape on the back of that? So go to the left.
Oh, is that on this one?
It's like right in between that bar. Like that. As you can see, probably after class you'll see this tan line on my face. But now you lost your duct tape.
That's right, I got a
But you
couple on
can
there.
hook it on the
Yeah, right there.
bar.
Right there.
That'll be good for the next 8 minutes, and then it's gonna go above. You're gonna have to like cut a slit in the cardboard and slide it up around.
It's right on the bar.
Just gotta engineer the crap out of this
So
thing.
you're gonna have like a tan line.
Yeah. Now I looked up there too much. Okay, so
My low-tech solution that I usually use when I'm in the sidewalk.
oh, that's all right. I'm good. I can see everything just fine. It's just hot. Yeah. So now we can check to see if the value is this. This is basically if is even. Otherwise is odd. So if it is even, we wanted to take the integer and add 1,000 to it and return its value as a string. So the value, we want to do a return of the value plus 1,000, and we want to return that as a string. And by default, that's not going to work, but we can do this. This will capture the returned evaluation of this value plus 1,000, and then we can use the dot operator on it to say toString, for example. Does that make sense? You can also do it kind of in a long form with something like this. And then we just say return new value to string. Yeah. Right. Yeah, we covered the toString just briefly, but it's you don't really think about it when you think about it into this. Ooh, yeah.
A little more duct tape here.
More duct tape is always the answer. Nice. Yeah, just duct tape it to my face.
So what does that dot mean? The
So the dot operator is accessing the methods and properties on new value. New value is an object. This is accessing the toString method. So if we looked at int, we can see that it has a method that returns a string, and it's called toString. This is actually the one I'm going to look at it here. So because string is an object, it has methods and it has data.
That also says override.
Yeah, don't worry about that for right now. Override just means
We're
that.
trying to figure this out ourselves.
Yeah, of course. Override is because it's overriding. Let's see, one of these guys. It's overriding whatever it's something that it's inheriting from. Something that's inheriting from says, here's this toString value as the default, and if you don't override it, then you're just going to get the object name, most likely. The default is to output the type. If you called toString on some other type, like my behavior, actually I think that's overridden in monobehavior, but if you're creating a new type and you just said toString, it would output the type, the name of the type. And so the string, the int method, the int object has overridden that. We can't see the method under here, but it's overridden that to take its integer and convert those numbers in the integer into characters and create a character string out of those numbers. Yep. F12. I think it's by a PC. Maybe? I'm not sure what it is on Mac. There's.
I'll figure it out.
Well, let me see what the command is in here. What it's called. Keyboard. Oh, it's here. Here. I don't know if you can reverse look up here. It's called edit go to definition. So if you look in edit here, there's a go to definition somewhere. So we've tested to see if it's inside the value range we're looking for. And now we've handled the condition if it is even. And so the next thing we have to do is test to see, if it's not even, then it is odd. So we don't have to do another test for that. And we can just return the odd value, which is create a new int. This value divided by 2. And then return new value to string. So just like, how did you do what?
Where would you see the debug thing?
Oh, so the debug thing. So in this, we could do that multiple ways. One of them is, so if we just we could attach the debugger. Attach the debugger, go back here. I don't know if that's actually attached to anything. Let's see. Yeah, the second option is to use debug log. We can go into attaching the debugger in just a little bit. The easiest way is to stop debugging, debug log, call our method. Debug log my method with integer. Our first example was 1.
And if you make that public, then you can access it immediately, right?
What public? Oh, yeah, if we wanted to define an integer here, we could do that. We could do it this way as well. Or you can just define, just do a bunch of them here. And you can even output it so it's pretty, so it's like 1 equals this. We'll just do a couple. Our second example was 55. So we can say 55. And here I'm just, this part right here is just to create a nice looking string in the output. So we can see we add my behavior to something.
So that's one thing, adding a script back to it.
Yep. The script needs to be attached to an object in order to be run. In order for that start method to be called. So here we saw our output, 1 equals 0, 55 equals 27. It's not our output values. Oh, let's see.
So if old and divided in 2 and you put int as a new value, should be that float because
Yeah, you're actually exactly right. This should be a float.
3 then it's 1.5.
Yep. Because I put those as integers, then the resulting value was cast to an integer, so we lost that 0.5 and we lost the 0.5. Still the same value. F. We need to define these guys as floats. So 0.5 and 27.5. And totally fine if you just output the integer values, because it doesn't say that they have to be a float value in the instructions. So that's not fine. Does that make sense? The primary goal here was to learn about checking values, have multiple returns in one method, and do some conditional operations. Okay, and then our exercise 2. Get rid of those guys. And if you didn't notice before, there's little pluses and minuses along the left side here. So you can shrink down methods to make things more readable. So if you've already written something, you know, I don't need to look at that code anymore, you can minimize it. So our other method was, it was just some code, this stuff. And it was written incorrectly, syntactically and logically, and we knew what the value should equal. The syntax errors aren't too bad because those are all highlighted. We can see that this is an invalid expression. That's because this is using the equality operator to try and do an assignment. So there's an integer sum we want to do set equal to 0. So that's just a single equals there. And all these i's, we see that the I does not exist in the current context. And that's because it was never defined. So we need to define it as an int I. And then lastly here we have int I equals 1, and then we say, oh, there's a semicolon expected, it says. So we can add our semicolon there. And now when we run it, This is where the logic, that was all the syntax errors. But now we can see that it does not equal, what does this equal? 500,500. That's what it's supposed to equal. Instead, it's equaling 499,500. And that's a logic error. A lot of you fixed it by just adding 1 to this, which technically does work. But someone reading this code later might think you're counting all the numbers from 1 to 1001. So it might be a little unclear. A slightly better way to do it, that's still correct for the purposes of this exercise. But a slightly better way to do it is to use a less than or equal to, which we'll get into today. It basically means that I is less than or equal to 1,000.
I was getting an error at some point whenever I was using.
The order matters. If you did it equals to or less than, that's not going to work. So it's less than equals to, which is probably one of those emojis those kids use today. The evil smile face? I don't know what that is. I always have to look them up.
Backwards fat arrow.
What was that?
Backwards fat arrow.
Backwards fat arrow. That's accurate as well. So that one was probably a bit tricky because we didn't get to for loops yet. So you may not have realized how it's supposed to be defined. And we're going to get into those today as well. Plus plus is a shortcut for saying I equals I plus 1.
So I think I, and then in you define, what you did is define integer I.
Yep, the integer is defined. So we're going to get to it when we look at for loops, but it's a parentheses, open and closed, containing 3 sections. The first section is a initialization. The second is the conditional for how long or when this thing is going to stop. And the third is the operation to perform each update loop.
So if you could define that integer outside of that for statement,
Yep, you can use a predefined integer. You could also define it this way. I is equal to 1 here. And you can actually leave that empty if you wanted to. It's just a bit clearer to have it all inside the for. If you have a reason for pulling it out, that's great. Like if you wanted to add up, just add something to this integer and then use it later. Yeah, like if you wanted to output the value of I at the end, you couldn't do it if you defined it in the for loop. So if you have a reason to do that, you should do that. But typically for clarity, you keep it all inside here. Now we can see that I is outside of scope. All right, the last exercise was the mover script. Let's create a new script called mover. And replace contents here. So I think a lot of you, whoops, replaced too much. We want to keep in our using statements there. I think a lot of you understood at least what this did because you put it into Unity and tested it out. And then you also, I saw a number of you used it to move your objects back and forth in your game, which is totally valid. So what it does is it moves an object back and forth. And let's take a look at it in Unity. We're going to move our mover, move those, and add our mover scripts. Defaults to speed of 10, direction of z. So that just moves it back and forth. Very simple. And how it does that is we keep track of, first of all, the speed and the direction. Those are just used in the calculation for moving it. Not super important, but we need them. The next one is the runtime, wait time, and the interval. Runtime, and you can see these are not defined public, so they're actually defaulting to private. It's because we don't need them exposed in the Unity editor. We could expose interval if we wanted to, so you can make objects that moved at different rates. But what it does is, about to get into that right now. If the runtime is greater than the interval and the wait time is greater than the interval, then we're going to negate the direction, the z. So this actually only works on the z direction. If you tried any other directions, it's just going to keep going somewhere. Then reset the runtime and the wait time to 0. The first time we encounter this conditional, it's going to return false because our runtime and wait time are starting out at 0, right? You could include the other axes here if you wanted to, and that would negate on all the other axes as well. Is that what you're asking? How to do the other axes? Yeah. You could also do a direction times equals DEV1. I think you can do that operation on a. This will the multiplication operator on a vector just multiplies each component of the vector x, y, and z by the float value that you find next. Yep, this is the same thing as doing the times equals is the same thing as doing direction times 1. It's just that same shortcut but used with the multiplication operator. You could also do the same thing with the subtraction operator, whatever else has things like that defined. So this is basically saying when runtime and wait time are both greater than the interval, then we're going to reset everything. That's what this is doing. Reset and change direction. Because we can see that we're resetting runtime and wait time to 0 here. So those will then be less than the interval. So the next time we come back here, this is not going to trigger again. So it only triggers once each of these is greater than the interval. And then,
show it again. I'm sorry. Can you show it again where you had all 3 axes laid out?
oh yeah. Just x, y, z and x, y, z, multiplying each one, so they're all going to invert along their own axes.
But it does all three off the dot. All three vectors.
Yeah, this is because this, this operator, you can see if you mouse over this operator, it says operator star, and it takes 2 parameters, a vector A and a float D. And how that works is it just multiplies that float D times each of the components. So this is the shortcut method of writing it this way. We'll leave it like that so it's a little bit clearer what's going on. The first time we're going to skip this block because runtime and wait time are 0. Then we're going to come and see that if runtime is less than 0, which in the first instance it's going to be, because runtime is equal to 0 and interval is equal to 0.3. So as long as runtime is less than interval, we're going to move our object in the direction and speed defined times time delta time to make it time dependent instead of frame dependent. And we're also going to increase our runtime by the delta time. And that'll be important in just a second. Here, if runtime is greater than the interval, then we're going to start adding up on the wait time until it's equal to or greater than the interval. So here we get as long as the runtime is less than the interval, keep adding to runtime, and eventually runtime is going to be greater than or equal to the interval. So it's going to stop moving. Okay, and then once it stops moving is when this guy is going to be triggered, because this is essentially saying the same as else do this thing, right? Because it's almost the opposite. It doesn't take into account the equals, but with floats, floats are so precise that it's hard to get actually something equal. So if you're counting up time and you want it to equal 0.2, it's very unlikely it's going to equal 0.2. It's going to be 0.2003468 or something like that. So they're never going to really equal. They might equal, but it's not likely. So and then we're going to, as long as the runtime is greater than interval, which is the whole time after this part of the code completes, we're going to increase our wait time. So now, after we've come through and run this block of code enough times, then both runtime and wait time are going to be greater than the interval. So runtime is run through, added up here, and then wait time is run through, added up here. Eventually, they're both going to be greater than the interval, and then we can switch direction and reset the values. And so what that gives us, so for example, if we gave ourselves a longer interval, it's a little more clear. We can see that the object's going to move in one direction, wait, move back, wait, move back, wait, move back, wait. And that interval is because it's going to move, going to continue moving until we've filled up the runtime with interval. So 1 second of moving. And after that, it's going to do this wait time, 1 second of waiting. And once both of those have been filled, 1 second of moving and 1 second of waiting, we reset and flip it. Now it's going to move back. 1 second, 1 second of waiting. Flip it. Set the value to 0, move back. And so it just gives us this oscillating function with a wait time at each end. Sorry, what was that? Yeah, runtime, anytime you define a float integer, the default's to 0. So this is the same as saying 0. It starts out at 0. We don't have to define these to start with because we want them to be 0. We don't particularly care about what they are to start with.
F at the end, you're declaring it there.
The F is only required when you have a decimal place in the definition.
Below that, the 1F.
Also not required. Yeah. F is only required when you have the decimal place.
So instead of doing an if else, could this have been like a loop? Or is that
No.
a completely different thing?
It couldn't be a loop because you would run. So let's try a loop and we'll see how it works. Okay. How would we want to structure that loop so it doesn't die? Well, so the reason you can't do a loop is because it's the code is the Unity is running, and every frame it's going out and it's calling this update method, and then it gets to the end of the update method and it comes back to Unity, keeps running all its other stuff, goes back, runs the update method, comes back. So you have to come back from the update method regularly, otherwise the game will just freeze. If you run something too long in that update method, it's just going to be stuck over there, and Unity is going to be waiting for that thing to come back. So if you ran this code in a while loop or something, it would just run in a while loop, and you'd never see it update on screen because it would never come back to Unity to say, hey, I've moved these things here,
Right,
I'm
we're
done. Yeah.
When Unity does that, does it get like stuck in a loop? Does it just like pause everything else and run other things?
It will pause everything else. If you had a while loop that ran for 2 seconds in your update method, then your whole game would pause for 2 seconds every frame. So your frame, each frame would be 2 seconds long. So it'd be this the stop motion. You couldn't close it. It would be. It's called an infinite loop if you had it run forever. But an infinite loop is something where the computer just goes and runs and never comes back to you. So that's why you have to be careful with loops. Same thing in the start method. If you got a loop in there, it's just going to run until the loop is done. And if that loop doesn't complete, then it's never going to come back. But we're going to get into loops today, for loops, while loops, do whiles, those kinds of things. All right, so does those exercises make sense? A little more sense than they did before, at least? Did anyone figure this guy out, how this works? It's all about stepping through the code, and you kind of have to keep the current state of things in your mind. And it for stepping through things like this, it might help to kind of have a running tally on paper. So you can have, you have one block that says runtime equals 0, interval equals this, wait time equals this. And then you say, okay, and then you check all your conditionals. This is going to return true, so this is going to run. Runtime is going to be incremented just a little bit. And then wait time is not going to be touched because runtime is not yet greater than interval. So that second block is going to look almost identical, except runtime is just going to be a little bit smaller. And if you looked at all the frames, you'd see runtime increasing, increasing, increasing until it got to the point where runtime was greater than interval. So each time this method is being called, let's minimize these actually. Let's see the conditionals better. So updates being run every frame, right? Every frame it's being called. The only conditional that's equating to true to start with is this guy, because runtime is still less than interval. And it's adding time to runtime every frame until eventually runtime gets larger than interval. Then we can see, oh, this part of this statement is true, but we need to, and we'll get into the conditionals like this later today. This part of the statement is true, but this part is false. And this and requires that both sides be true for this to be true. Yep. Runtime is just a variable name we made up. Wait time is also a variable name that we made up here. There is a variable in time called, it's called game time or just time, I think. This is the time at the beginning of this frame. Let's see, there's something that keeps track of the entire game time. It's not in delta time. Sorry, I couldn't hear. Time is going to be, it's not like the computer time. It's the time since the beginning of the frame or the time since the application started. And time is going to be constant across all computers, unless there's somehow they have a fast clock or something like that. We can only rely on the clock of the computer. So time is going to be constant across all computers, which is why you want to use time instead of relying on the frames to do things, the number of frames. But runtime is just one that we made up. So we've run through each frame. We saw runtime increasing till it got to the point where it was greater than interval, and now this guy's still not triggering, but it's halfway there. Now this guy is not triggering anymore because it's no longer less than interval, but this one is going to trigger because it's greater than interval. Okay, so now this guy is triggering greater than interval, so now we're going to be increasing wait time. So you can see once we started, we're increasing runtime. We got to the point where it was at interval. Now we're going to start increasing wait time, and eventually that's going to get to the point where it's greater than interval as well, and that's going to complete the second half of this conditional. So it's like if you imagine two bars filling up, runtime fills up, tops off, then we trigger wait time to fill up, top off. Once both of those are full, which is what this is saying, runtime is greater than interval and wait time is greater than interval. Once both bars are full, we flip the direction and reset those to 0. Yep. If runtime is greater than interval, and this is the and conditional, which we're going to go in today. It's an operand. And wait time is greater than interval. Then we're going to run the code inside here.
Oh, I see. It's not.
Yeah, sorry, I minimized this just so we can see everything easier. If these two are true, then we're going to flip the direction and reset our runtime and wait time here. Yeah, we're gonna these are two separate. So this is if we put parentheses around these here and here, we can see that those are two separate things. We're going to evaluate these first, then evaluate the combination of them. Yep. This is flipping the direction. So it's taking, so if you're going positive 1 along the x-axis, you multiply 1 times -1, you get -1. So then you start moving along this way. If you multiply -1 times -1, you get +1. You go that way. And it just goes back and forth. Yep.
So if you have all three of them, does it then go, oh, well, then I can't go any direction because I can't go all directions at once?
It can go all directions at once. You can go on the X, Y, and Z directions at the same time. Because so this is, it's moving around on the floor. So let's shrink it down to 2 dimensions, right? You can move on the x-axis back and forth, but you can also move on the y-axis at the same time, which is then the diagonal movement. And you can move on the z-axis at the same time. So you get 3 axes of movement there. So you can move on all axes at the same time. That's what this is doing. And you can reverse the direction on all those axes at the same time too. Stuck on what? That's down here in the, when we're moving things, we're taking the position and we're adding the direction times the speed times delta time. If wait time is greater than interval, so if both those bars are full, if we've moved and then we finish waiting, now we're going to take that direction that's pointing this way, we're going to multiply by -1 to point that way, and then we're going to reset. So now we need to fill up our bars again by moving, waiting. Now we're going to flip it, moving, waiting, flip it, moving, waiting. So you understand the waiting part and the moving? That's correct. Yep. Yep. The direction is set in the Unity editor here. Our direction is set here to forward. So right now we've defined a direction of forward, which is the positive z direction. So along the z-axis, forward is the z of 1. And then when we flip it, we multiply that z by negative 1. So now we're pointing that way. We move that way. It's not actually rotating the object around to face different directions. It's just moving it in different directions.
But then when you come back, holding that negative, because now you're not going forward, you're going back.
Yep.
How is it holding that backwards? Come around.
We're resetting the direction value to the direction value times negative 1. So now, after this guy is triggered, then this is no longer going to equal forward, it's going to equal back. It's going to equal negative 1. Let's take a look at it in Unity. You can see, so if you can see the value down here is swapping between 1 and, whoops, I can't be clicked on it. It's swapping between 1 and negative 1 as we move. So that value, it's holding that value by storing it in that variable right there. The equivalent of z1. So that's the forward is the same thing as a new vector 3 of 0, 0, 1. You can see that that's just a shortcut. There's back, down, up, left, right, forward. It has all the cardinal directions in there. Okay, does that make sense to everyone?
Could I do instead of forward vectors or define all three vectors right there?
Yeah, well, not in the version that you have, but because we updated ours to do all 3 directions, that'll work. So we could do 0.43, 1, and F after these. So we could do whatever direction we want, and it's going to move.
I was just trying to actually do that at the I didn't have the word vector.
Except it's defined in Unity editor, so we should actually change it in here. So it'll flip along all axes. I mean, you can have them start out negative, and they'll just all invert. So we should probably move on, or we're gonna run out of time. So if you have further questions, you can ask them on Slack. So let's take a quick break, and then Tim is going to give you a motivational speech that's going to be very inspiring and awesome. And you should really be hyped up about it because it's going to be great. And then we'll get into some control flow and the Boolean logic.